Okay. For concept 20, let's start by looking at graphing absolute value, not inequality, but absolute value. Okay, so graphing absolute value equations. And it's actually a very simple technique because all the stuff that we learned to graph lines, we're going to use here. Okay, all those different things that we learned for that, we're going to use in this case. So graphing absolute value. Here's what I want to do, and it's the easiest way for you to learn on your own what an absolute value will look like. Many of you may know already, but it's a simple way to. Start by looking at the function f of x equals absolute value of x. Make yourself a table. So make a table of data points. For your x values, use -3, -2, -1, 0, 1, 2, and 3. For your y values, I want you to tell me what they would all be. It's a very not a difficult task I'm asking you to do. But take the x value, plug it into the function, see what comes out of the y. 3. Choose yourself.
That's you, John. You said everybody. You're not included.
So, everybody, what's the absolute value of -3?
3.
-2?
2.
-1?
1.
And on the other side?
5. 1, 2, 3.
So what do you notice about all the y values in this case? They're all positive, right? They're all positive. So if I were to plot these as points, my first point is -3, 3. 1, 2, 3. 1, 2, 3. That's this point right here. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. 3, 3. Now, if I connect these, what will it look like?
A V.
A V.
For Vanessa.
For Vanessa. It is a V shape, yes. Now, the important part to think about is this. On the right side of this graph, so everything to the right side of the y-axis, what equation represents that line? Again, just this portion right here. What, without absolute value, what equation can I write to represent that line? Y equals what? Y equals x. This is the line y equals x. Again, how do I know that? I'm going up 1 over 1, up 1 over 1. And what was my y-intercept here? 0. So if I go up 1 over 1, it means there's a slope of a 1 here, and there's a y-intercept of a 0. So really I'm looking at the graph again of y equals x on the right-hand side. Now, what about on the left-hand side? What am I looking at? What is it? -x, because look at the slope. Is the slope going up still? On the left side, what is it doing?
It's going down.
It's going down. When the slope is going down, we have a -1 or a negative slope in general. In this case, we'll see. We go down 1 over 1, down 1 over 1, down 1 over 1. Thus, my slope is -1. What is my y-intercept still?
0.
It's still 0. So this equation is y equals -1x plus 0, or simply y equals -x. So here's what you're going to notice. For the rest of the day, this will be consistent. Your slope will be the same on both sides, but one will be positive and the other will be negative. Okay? It's going to be the same for the rest of the day. We're going to do a little more stuff with this, but the general idea is the same. Whatever your slope is on the right side of the vertex will be the slope on the left side of the vertex. Who remembers from last year? You all should, but let's see. What is a vertex?
Oh, it's the point of an angle.
Okay, the point of an angle, sure, but let's make it a little bit more specific, if that is true. Anna?
Can I give an example?
Sure.
Like, a pyramid at the top with pointing side.
Very good. That's like a vertex there. Good example. The point at which two, we don't want to say lines, because two lines mean it would be an intersection. Two rays. Two rays. Okay? So again, take a look here. This is your vertex, because the two rays meet at that point. Again, if there were two lines meeting there, we would simply call it an intersection. Two lines is an intersection. Two rays meeting at that value is a vertex. All right. With that said, let's get into today's lesson now. That was just a little preview. If we look, this is going to be our general equation for the day. And if you remember this from concept 15 when we did transformations, we did sliding left and right, sliding up and down, and if A is positive or negative, it opens up or it opens down. Again, I was not joking with you guys. We're going to use it with every single function we graph this year. We're going to use A, H, and K. That's how important concept 15 was. Now, looking at this one, does anybody remember what H represents? Juliet? Horizontal, good. Left and right, think of horizon when you do this. The horizon goes like this, horizontal. So again, H represented the horizontal translation. Next. There we go. Good, the vertical shift, or the vertical translation. You can use the word shift or translation, it does not matter. Same word. Finally, what did A tell us? Juliet?
Isn't it like flipping it?
Good. If A was negative, then we have to flip it, right?
Yeah.
In this case today, here's what we're going to know. If A is positive, so if A is greater than 0, it opens up. If A is less than 0, it opens down. Okay, again, if you look at the first example we just did, the value of A was 1. There was a 1 in front of the absolute value. And it was positive, thus it opened upward. If we have a negative A, and we'll see that in a minute, it's going to open downward. Again, a positive A, that's greater than 0, means opens up. A negative A, it opens down. Okay, any questions so far? We're going to go through a few different examples of graphing, so make sure you keep up. Please make sure you are labeling your axes. Okay, make sure you are labeling your increments. Make sure you're using a straight edge. I know it's your notes and you don't have to, but maybe it'll practice because a lot of people keep forgetting that still. Okay, if we were to draw a quick sketch of what that meant just now that we talked about, let's draw that. So, this shape was the shape that we had earlier, that V shape. We can call that our parent function. Have you ever heard that term before? Okay, let me explain that. Think about it. A parent, or your parent, is somebody that is very similar to you in your genes. You're made up of, your parent genes from your mom and from your dad. This is called the parent function because every function we do from this point on for absolute value will look like this, but it will be a little bit different. Like you don't look exactly like your parents, you always look a little bit different, right? So in this case, this is our parent function, and that governs the general shape of the graph. Now, we talked about if we have a horizontal translation, and say we have a vertical translation, and let's say now our graph is here. The new graph will still look similar, but it has a horizontal and a vertical translation.
Which is the parent?
The parent is the red. Okay, the parent is the red. This is my horizontal translation. This is my vertical translation. So depending on the chatter has to slow down a little bit. Sit over here, Dad. So you can see the back. Just face this way so I can see where you are, please. So here we've got H is our horizontal translation, K is our vertical translation. So whenever we do this kind of stuff, that's all we're going to do. Whatever H is, we're going to move in that direction. Whatever K is, we're going to move in that direction.
So can we call that that V that you horizontally and vertically shifted? Can we call it the child?
Sure, you can call it the child. I was wondering where you're going with that. Now, what would this vertex be right here? This vertex here is 0, 0. How would I label that vertex?
Oh.
Well, I mean, it's not drawn scale.
Doesn't matter.
Oh, well then. Yeah.
Okay.
No, that'd be.
Zero. Come on, Jared. You have to check. 0. Okay. And then over by 0 plus K.
Very good. Jason said this is going to be 0 plus h, because what's our x-coordinate right here? It's h. That's what this is. Again, this is like saying 1, 2, 3, 4, but we know that this distance is h. Thus, the x-coordinate is h. You don't need the zeros, obviously, right? And then this is going to be k. So again, this was shifted up. This is a height of k. This is a width of h. That's what that represents. So the coordinate of your vertex, your new vertex, will always be h and k. Whatever h is, whatever k is, that will be your x and your y coordinate of your new vertex. H is the x value, k is the y value. Okay, let's go into examples now.
Half a second. That sounds so good right now.
Okay, our first one we're going to look at. Y equals absolute value of the quantity x plus 4 minus 2. Okay, our goal right now is to graph this and compare it to our parent function. See what the difference is here. That's all we're going to be doing. Now, I could sit here and plug in values, sure, always. I can make a table. But based on what we said a minute ago, there's an easier way to do this problem.
Go over 4 and under 2.
Well, let's start by labeling what we know, okay? What does the 4 tell me to do? Over 4, which way?
To the left.
To the left. Look at your parent function. Remember, this says x minus h. So the value of h in this case is not 4, but negative 4. Remember, it's whatever the opposite of that is for h. H is negative 4 here. What is the value of k, everybody? Negative 2. You leave that one alone. Same thing as concept 15 again. The h value is the opposite of that value. The k value is the same value as that value. Now, the h represents the horizontal, the k represents the vertical. So where should I go? What point should I go to?
Negative 4, 2.
Negative 4, negative 2. Again, my vertex is simply hk. Well, there's my vertex. So if I go over 1, 2, 3, 4, go down 2, here's my new vertex. Okay, there's my new vertex. Now, how do I know how to draw this graph? I don't know what the slope is. Earlier, we had the slope. What's the slope of this one going to be? Derek? What's in front of the absolute value, guys?
Y.
I'm sorry, before, like, what's right here? What really is here?
0.
Not a 0, is it?
1.
A 1. Again, this is really a 1 here. Whenever you have a number by itself, or a variable expression by itself, there's always a 1 in front. Which means that a in this case is 1. So our slope is just 1. But we know from the last example that it's not really just 1, it's 1 and it's negative 1. Because again, everything to the right is a positive slope. To the left was our negative slope. So here on the right side, I got to go up 1, over 1. Up 1, over 1. I don't need to do any more points really, but just to show, I can keep going up 1, over 1. On the left, what should I do?
Same exact thing.
But go which way?
To the left.
To the left. Look at my original function. So what are you going to notice again? The same shape exists. Okay, so to graph this example here, we need to start. Okay, if you want to write down some steps, here's what I would think about. Your steps are start with your translation. Start with your translation and graph your vertex. Start with your translation and graph or plot your vertex. Okay, that's step 1, plot your vertex. Step 2, identify your slope. Identify your slope. Now, in this case, there was nothing there. That's what makes it a little bit tricky. But there's really a 1 in front. So my slope was just up 1, over 1. Up 1, over 1. Now,
What if it's like a 2?
if it's a 2, I go up 2, over 1. Up 2, over 1. Now, If we had a -1 instead, what would this graph head look like?
Go down.
Good. It would look like this. If the 1 had been negative, or if the A value had been negative, like we said, the graph would not look like this, but it would look like this, shaped downward. Ashley. Sorry, you go up 1, over 1, put a point. Up 1, over 1, put a point. Once I have these 3 points here, I can stop, actually. I just kept showing you more examples. But again, you don't need that many points. All you need are these 2 points to make this point, this line, these 2 points to make this ray. Okay, to make each ray on each side, all you need is 2 points.
So can you do that on example?
You need 3, 2 for each, but one of them is overlapping, yes. Just 3 points? Absolutely. Of course. Guys, again, I'm only going to use 3 points from this point. I'm not going to show all these. I was showing you as an example that it will continue the same slope the whole way.
So if that one was a -1, it's going down, but it's also going to be also a positive one.
Because on the other side, it's a positive one, yes. And we're going to talk about that one in a second. Okay, let's try another one.
Yeah, the classic SpongeBob.
Yeah, I think that's SpongeBob. SpongeBob's a little silly.
Okay, let's try these two now, so we can analyze what the slope does.
Yeah.
So we're going to drop the translations for now. We're just going to look at slope right now. We're just going to look at slope. In the end, what do you think we're going to do?
Graph it.
In the end, we're going to graph the whole thing now. So, looking at f of x. Looking at f of x, what do I see here? Is there any translation at all?
1.
Is there a h and a k for f of x?
No.
Is there a h and k for g of x?
No.
So that means that the vertex will be on the origin still. It will not move. There will be no horizontal, there will be no vertical translations. So in this case, I can already start by putting my vertex for f of x right here. And I want to put my vertex for g of x. Well, it's also right here. So there's no problem with this one. I don't have to move anywhere. Now, the thing that I do have to look at is my slope. For f of x, can somebody come up and draw what that one would look like for f of x? Simply based on the slope. And
Or F of X?
f of x, just give me the points for it.
I was
You need
saying,
the line.
handicap all of the G.
E pounds, remember?
Oh, yeah.
Right? Yeah.
Man, watch me break my arm driving a car.
If you'd like to, sure.
Oh man, you didn't miss that.
Vanessa, when you're done, turn around and explain to the class what you did. Your chance to teach. What were your broken phone?
Well, what I did was I looked at the A value, and it's 1/2, so you go up 1 over 2.
And why did you do on the other side like that? You went up 1, left 2. Why'd you do that?
I don't know. Yeah, we're very good.
It's not because it's the
I know,
opposite.
right? That's tough.
That's why you don't listen.
She went up 1 and over 2 because the slope was 1/2.
Oh, because it was
Because it's still positive, very good. Because it's still positive, because it's absolute value. Very good job. Again, think about this. A slope of 1/2, you would normally go up 1 over 2 or down 1 over 2. So for a line, your line would have been right here, and the line would have continued throughout this way. But clearly, since we have absolute value, we don't have this negative portion here, so it goes back up in this direction. So this part does not actually count here. Okay?
right.
She was correct. Very good. What about the next one? Can anybody do the next portion? Here you go. Use the blue. Here you go.
All right, Miguel.
Let's let him do it first, then we'll pass it again. Assume when he gets it right.
I hope so.
I hope so too.
I don't even want to do this.
Jason, sit down.
I'm just talking.
No, sit down.
He's like your dad. Shut up.
Three yes.
That's the 3. Oh.
He's counting by 1.5.
1, 2.
Does he look like Jason?
Connect.
Does he look like Jason?
I
He's
I meant
brother like
personality.
6 years.
I meant personality.
Oh, your brother?
He's coming.
Yeah, he's just like Jason.
Is that right?
Very good. Let's take a look. Miguel, don't go anywhere. You gotta tell.
Yeah,
What did you do, Miguel?
That's
Get
the
over there.
A value was -3, and since it's only -3, you should just put a 1.
You gotta start over and do a little bit louder. Can you guys hear him? Is he in the back? Yeah. See, it looks like they can't. Nice and loud.
Alright, so the A value is -3, and since it's only a -3, you have to put a 1 under, so it's going to be -3/1. So you just start from 0, 0, and you go down 3, and then since it's negative, go to the left 1, and then you want to do to the opposite, so it could look like a B.
Very good. Again, you noticed. Very good. Good job. The A value was negative, so the graph has got to open downward. Again, the graph here opens downward because it's negative. And then he looked at the slope and it was 3, so he went down 3 over 1, down 3 over 1. Again, when you see a number by itself, put it over 1 so it helps you as a slope. This tells me go down 3 over 1, down 3 over 1. Again, it doesn't matter what the number is right away. You want to look at the sign first to see which way it opens. Yes? I didn't love that shit,
He's in the parking lot. We need your flip flop in the middle.
Now let's try the next one.
Did you hear It's that way we were late and
That way.
yeah. Oh, look at the concepts.
It's the one you took today.
Yeah, get the answers. I know. That's how much I know.
This is the one that we took
I got
today.
2 my shit.
Derek.
Don't let me start, okay? Cuz you're here. You exist. That's why I'm angry.
John, calm down. You're joking. Calm down.
I'm sorry.
I've been emotionally scarred taking you to court.
Yeah, I was about to say you were so big.
He said,
20 years in prison. What? 20 Alright.
Negative 1, not 1.
Oh, right. My bad.
I didn't want that to happen.
I was right.
Okay, try this one on your own. Here, I'm going to give you a hint. First translate, plot your vertex, then do your slope. Again, please, translate first, plot your vertex, then work on the slope. You said I was going to do it in about a minute. You got 1 minute to get this done. It should only take you about 30 seconds.
I'm gonna H equal -1.
Again, try it on your own, then we'll go over it.
I don't even know how to read it. How do you read my handwriting?
Yeah.
Here's the practice.
My name is Mac Miller. And you're now into the.
Bring down the prompt.
Does anybody have any food? I'm hungry, seriously. Last thing I had was lunch yesterday, man.
You're over here.
Anybody have
that wasn't even lunch, that was breakfast.
breakfast?
Let's not draw one graph. Oh, sit over here now.
Can somebody bless me?
You guys didn't have to draw the graph.
I thought we didn't have to draw them.
When have I ever said that?
I never drew drawn a graph.
Oh, you moved Julia?
Yeah.
Guys, the whole concept today is graphing equations. Make sure you are doing the graphs. Don't just spectate, actually participate.
I can do some crap.
You sell it, Jack.
Sell
We can do
it.
the next one. Come on up.
She's too far. I could have done it by the process and got up here.
Yeah, I didn't know.
I'm like, oh my god. I do
Boy.
I showed you by your sweater.
What?
No,
You
there's not.
Sure.
You should have.
What? Whoa.
Anyway.
Dang, I never, not even I said that, dude. Dang.
I'll get hostile. I'll hit you by your thumb.
Oh my god.
Look at her, she wrong.
Shut up!
That's
Shut
her.
up!
Make your dot nice and big so people can see it. There you go.
Yeah.
And give me 2 more dots before you make the mark.
Okay. 2/3. Okay.
She's correct so far.
2.
Again, h in this case is -1, not 1. Remember, h is the different value of what's on the inside. It's the opposite.
1, 2,
Awesome job.
Yay.
Exactly right.
Now connect.
Again,
Hold on.
your slope here was 2/3, and it happens to be positive. Thus, you are opening upward. She went up 2 and over 3 from the vertex. Then she went up 2 and left to the 3 for the other point, and connected them. Great work.
Why is it on the negative?
Say it again, Julia.
Why is it
Because
on
the
the
Over here.
H is positive 1.
So h slides over to the 1 here. Then it goes up 3. Okay?
This highlight.
Again, we have how many points here? 3 points you need for this. You need the vertex, and then another point in each direction to indicate each ray. Again, this is 2 rays coming from the same point here. Try one more, and then I'll give you a homework. You guys can get started on it.
Who's Alexis?
Okay, if it's stressed down, are we still allowed to wear hats?
No.
For transition.
Yeah, I would have been with my hat. There was a, he told me to do
You look like an army cat.
Quiet.
Yeah, you look like
Because you guys saw the new video with the model.
Jason, you look like the noob.
Leave. Let's do something at John.
I heard their house laugh.
Oh, I know what you mean. The Call of Duty commercial? Yeah, I get it. Yeah, with Jonah Hill and Canelo. Yeah.
It's actually really cool.
I did like 10 hours.
I thought that was a cool commercial, you know?
Sorry, yeah. I like it.
Try this one on your own, please. Again, translate, then use your slope. Keep in mind here, your slope has a certain value in front of it this time. So it has to open a certain way. Make sure you remember that. Derek's going to put it up in about 2 minutes. This is the last one. You can do the next 6 for your homework in a minute.
That's the next one. That's the next one. Don't worry, big guy.
I like to solve for other.
No, absolutely. I'm saying check. It's supposed to check. Give another minute, Derek. Give another minute, please.
Mr. How come some of the notes aren't the same as some of the They're weird.
This is the joint with the yes, this is what I saw when all the MMA practice with the bar.
No, some of them are different. Some of them are short.
Oh, yes. Sometimes I do more teams.
Jason was like that one.
These are like the general examples. So we're on the last
Jason, have you ever seen the Assassin's Creed commercial?
Yeah.
Where they like pop their video? You look like that one white guy.
That's vicious though.
I know, I'm being assassins and
That
like,
commercial was pretty.
Yeah. I don't know, use all the expressions like Derek Rose.
Most dope. Where are we? Horizontal.
No Spanish?
Hey, just as a survey, guys, if we start the Saturday SAT quiz, when would you guys want to start?
December.
After Thanksgiving break or Christmas break?
Christmas break.
Start what?
Thanksgiving break. I say Saturday.
Show of hands after Thanksgiving break. We do an SAT class on Saturday.
What time would it be?
On Saturday? Or like 9 to 11?
Oh, yeah.
Youth ministry is at noon, I think, on Saturdays, right? Isn't that when you guys meet?
From
11:30.
What is it?
11:30.
11, okay. So then 9 to 11 works fine, it gives you a half an hour break. And then after Thanksgiving, or after Christmas, the other one. I gotta talk to Mr. Smith.
She said, what against 10?
Mr. Half. Half.
Oh, yeah.
I feel like I'm messing up something. I feel like I'm messing up something. No, I got. No. Yeah, two. That's what I got. There you go. This is -5.
Down 5 over 2, down 5 over 2.
What's the half? Since it's -5, don't I go? I go down 5 and then over 2, right? Yeah.
Andrew already took it.
As Derek gets finished, check your answer and start your homework here. Should be with black. Math. Chemistry, history.
My middle school managed.
Yeah, you're good.
Okay, so we can see. Real quick, guys, last one. We'll see we went to the right 2 units. We went down 4 units. There's the vertex right here. Now, once the vertex was plotted, the slope was negative, thus it opened downward. So you go down 5 over 2. So Derek went down 5 over 2, down 5 over 2, connected, he's got a shape. Now, one of the things about your homework that you need to consider, if you look at your homework, you're only given a graph that looks like that. Make your axes work. So before you start graphing your x and y axis, think about which way you're going to be translating and which way your shape is. Let me give you a quick for example. So, right now you guys have...
Yeah, and it broke.
Do you want to sneeze in the world?
You can hear pretty trap.
Okay, this is what you guys have on your paper right now, just a 10 by 10 grid. Now, if I gave you an example that said, let's say this is your example. It's not on your homework, but I want to show you because some people are messing this part up. Right away, what do you see? You're going to, hold on, Leonie. You're going to translate to the right one
And then down to
and down 2. Now, which way are you opening? Up or down?
up.
Up because it's
Positive.
positive. It's positive. So you're opening up. If this were negative, you'd open down. So open up. So take a look and think about this. You're going to go to the right one, down 2, and open up. So eventually, I'm really going to be in the 4th quadrant. Again, if I were to sketch this in my mind, here's what I'm thinking. Right 1, down 2, opening up. That's what my general graph will look like. Again, to the right 1, down 2, there's my vertex, and opening upward. So I care about the 4th quadrant mainly. So if I were to graph this one, I might make my x and y axis right here. Make that my x-axis, make that my y-axis. Because I know most of my detail will be in this quadrant. Does this make sense? Okay, you want to specify what you're looking at. If you draw down the middle, you might run off the graph. So you have to make your axes so that you can fit. Every example for your homework you can do. If you draw your axis normal, down the middle on both sides, it might not fit. So think before you actually draw. So right 1 and down 2 would be here. I'd go up 2, over 3. Up 2, over 3. And this would be my graph for this one. Okay, is that clear? When you have a graph or a grid that is not infinite in size, you need to use it to your best ability. So draw your axis in a location that optimizes the problem, or that optimizes your graphing situation.
Yeah.
Oh my god.
Go ahead, Leonie.